December 22nd marks the 133rd anniversary of the birth of legendary Indian mathematician Srinivasa Ramanujan. An intuitive mathematical genius, Ramanujan's discoveries have influenced several areas of mathematics, but he is probably most famous for his contributions to number theory and infinite series. Among them, most fascinating formulas that can be used to calculate the digits of pi in unusual ways. Ramanujan's story is dramatic and somewhat larger than life. It is one of the most romantic stories in the history of mathematics. In 1913, the English mathematician G.H. Hardy received a strange letter from an unknown clerk in Madras, India. The 10-page letter contained about 120 statements of theorems on infinite series, improper integrals, continued fractions, and number theory. Ramanujan was born on 22nd December 1887 into a Tamil Brahmin Iyengar family in Erode, Madras Presidency, at the residence of his maternal grandparents. His father, Kuppaswamy Srinivasa Iyengar, originally from Thanjavur district, worked as a clerk in a sari shop. His mother, Komalada Ammal, was a housewife and sang at the local temple. They lived in a traditional home on Sarangapani Sannidhi Street in the town of Kumbakonam. The family home is now a museum. On 1st October 1892, Ramanujan was enrolled at the local school. After his maternal grandfather lost his job as a court official in Kanchipuram, Ramanujan and his mother moved back to Kumbakonam. When his paternal grandfather died, he was sent back to his maternal grandparents, then living in Madras. He did not like school in Madras and tried to avoid attending. Within 6 months, Ramanujan was back in Kumbakonam. At Kanya Primary School, Ramanujan performed well. Just before turning 10, in November 1897, he passed his primary examinations in English, Tamil, Geography, and Arithmetics with the best score in the district. That year, Ramanujan entered the town higher secondary school where he encountered formal mathematics for the first time. A child prodigy, by age 11, he had exhausted the mathematical knowledge of 2 college students who were lodgers at his home. He was later lent a book written by S. L. Loney on advanced trigonometry. He mastered this by the age of 13 while discovering sophisticated theorems on his own. By 14, he received merit certificates and academic awards that continued throughout his school career. He completed mathematical exams in half the allotted time and showed a familiarity with geometric and infinite series. He was shown how to solve cubic in 1902. He developed his own method to solve the quadratic.
When he was 16 years old, he obtained a copy of George Schubert's Carr's Synopsis of Elementary Results in Pure and Applied Mathematics. This collection of thousands of theorems, many presented with only the briefest of proofs and with no material newer than 1860, aroused his genius. It was in no sense a mathematical classic. Rather, it was written as an aid to coaching English mathematics students facing the notorious difficult Rikers examination, which involved a great deal of wholesale memorization. But in Ramanujan, it inspired a burst of feverish mathematical activity as he worked through the book's results and beyond. Having verified the results in Carr's book, Ramanujan started developing his own theorems and ideas. But his life took a decisive turn due to it. The next year, Ramanujan independently developed and investigated the Bernoulli's numbers and calculated Euler-Mascheroni constant up to 15 decimal places. His peers at that time said they rarely understood him. He graduated from Town Higher Secondary School in 1904 and received scholarship to study at Government Arts College, Kumbakonam. But he was so intent on mathematics that he could not focus on any other subjects and failed most of them, losing his scholarship in the process. He later enrolled at Pajayappa's College in Madras. There, he passed in mathematics, choosing only to attempt questions that appealed to him and leaving the rest unanswered, but performed poorly in other subjects such as English, physiology, and Sanskrit. Ramanujan failed his Fellow of Arts exam in 1906 and again a year later. Without an FA degree, he left college and continued independent research on mathematics under extreme poverty and at the brink of starvation.
Ramanujan continued his work without employment and living in the poorest circumstances. After marrying, in 1909, he began a search for permanent employment that culminated in an interview with the government official Ramachandra Rao. Impressed by Ramanujan's mathematical prowess, Rao supported his research for a time, but Ramanujan, unwilling to exist on charity, obtained a clerical post with the Madras Port Trust. In 1910, he met Dr. V. Ramaswamy Iyer, founder of the Indian Mathematical Society, which gained him some recognition in Madras Mathematical Circle and finally led to his inclusion in the University of Madras as a researcher. In 1911, Ramanujan published the first of his papers in the Journal of the Indian Mathematical Society. His genius slowly gained recognition, and in 1930, he began a correspondence with the British mathematician Godfrey H. Hardy that led to a special scholarship from the University of Madras and a grant from Trinity College, Cambridge. Overcoming his religious objections, Ramanujan travelled to England in 1914, where Hardy tutored him. Ramanujan's knowledge of mathematics was startling. Although he was almost completely unaware of the modern development in mathematics, his mastery of continued fractions was unequaled by any living mathematician. He worked out the Riemann series, the elliptical integrals, the hypergeometric series, the functional equations of the zeta function, and his own theory of divergent series. On the other hand, he knew nothing of the doubly periodic functions, the classical theory of quadratic forms, or Cauchy's theorem, and he had only the most nebulous idea of what constitutes a mathematical proof. Though brilliant,
In England, Ramanujan made further advances, especially in the partition of numbers. His papers were published in English and European journals, and in 1918 he was elected to the Royal Society of London. In 1917, Ramanujan had contracted tuberculosis, but his condition improved sufficiently for him to return to India in 1919. He died the following year, generally unknown to the world at large but recognized by the mathematicians as a phenomenal genius, without peer since Leonhard Euler and Carl Jacobi. Ramanujan left behind 3 notebooks and a sheaf of pages containing many unpublished results that mathematicians continue to verify long after his death. India's mathematical heritage extends far beyond Ramanujan's time. The nation is considered home of the concept of zero, founded by the great mathematician Aryabhatta. India is also the home of our decimal numeral system.